All right, so there's nothing new or really different about x-intercepts and y-intercepts here, except for just as with quadratics, you're not always guaranteed to have an x-intercept. So let's look at y. The x-intercept is the place where the graph intercepts the x-axis, and the y-intercept is the place where it intercepts the y-axis. So assuming that you have an infinite domain, that you can plug in whatever you want and you're not restricted by anything, you will have a y-intercept pretty much every time. The y-intercept of this example 1 is right here at 1. Okay, it is going to be the point 0, 1, because I'm not going side to side at all, so my x value is 0, and I'm going up 1. The fact that that x value is 0 is really important because if you don't have the graph, you can find this algebraically. The y-intercept is always going to be the point where x is 0, so you can just plug in f of 0 equals 2 to the 0, and 2 to the 0 equals 1. So that's algebraically why my intercept is 0, 1. The x-intercept is a bit interesting here because we just finished talking about asymptotes and the fact that this thing is approaching the line y equals 0, but never actually touching it. If it never reaches a value of y equals 0, then that means it never gets an x-intercept. Therefore, there is no x-intercept. It does not exist. And that is going to happen with exponentials from time to time. If you have an asymptote of y equals 0, then you don't have an x-intercept. Because algebraically, if I wanted to find the x-intercept, then I'm going to plug a 0 in for that f of x. But we just talked about how that can't happen. We can't get 0 there. Okay, when I look at this one, it's a bit different. Again, my y-intercept, pretty easy to find. It's right there. So my y is going to be the point 0, 3. Algebraically, you would put a 0 in for x, so we would have y equals negative 1/2 to the 0 power. Oh, I put those in the wrong spot. You would have negative 1/2 to the 0 power. That negative's got to be on the outside because it's not getting raised to the exponent. And then plus 4. Well, 1/2 to the 0 power is 1, so I have negative 1 plus 4, which is 3. So my y-intercept is 0, 3, because I plugged in 0 and got out 3. The x-intercept this time, it does cross the x-axis because my asymptote's in a different spot, so it's not approaching that 0 anymore. I cross the x-axis, and graphically it looks like it is at negative 2. So that's going to be negative 2, 0. Now, technically, you could do this algebraically by saying 0 equals negative 1/2 to the x plus 4 and solving this equation. We don't yet know how to solve for an x that's inside of that exponent, so don't worry about trying to do that algebraically. You're always going to be able to find it graphically, okay? Even if we ask you to find the x-intercept, it's either going to be a super simple problem, which we'll teach you how to do later in the unit, or it's going to be a situation where you have the graph and you can look, or you can use Desmos to pull up the graph and look at it, okay? So don't stress about that. Go ahead and pause now and give me the y-intercept. Notice I'm only asking for y, not the x. I'm asking for the y-intercept of these exponential functions. You can pull up Desmos and graph it if you want. Remember that website is desmos.com, and you can graph it. Ask for help if you need that. It's also probably a good idea to practice plugging in 0 for that x to get your y-intercepts. All right, so go ahead and do that. Let us know if you have any trouble, and then go on to the next video.